Okay, so in the last review, we're gonna explain a very complicated thing, which is the dynamic imperfect information game. And in this signaling game, we need to find a weak sequential equilibrium, impure strategies, and you need to find whether there exists such kind of equilibrium that player 1 chooses a different action depending on its type. And that means if player 1 is a one type, they choose a specific action, but if it's another type, they will choose a different action. We can also put it in the name of separate strategy, right? Depending on the type of player 1, you will use different action. So we just need to find one such action profile, one such equilibrium, and that's it. So let's first assume that for player 1 at decision node H1, you will play A, and as I said, it's kind of separate strategy. At decision node H2, we assume player 1 will play B. So we write it this way. Assume that for player 1 at decision node H1, the probability of playing A equals to 1. And for player 1 at decision node H2, the probability of playing B equals to 1. Okay, so this is our assumption. And given this assumption, we need to find out what will be the action profile of player 2 in the information set IB. And also, what is its action profile in information set IA. Okay? And now let's first look at IB. So given that player 2 finds that player 1 plays B, and what will be his action profile in this information set? If player 2 plays L, she gets 3. Play R gets 1. So player 2 will play L. So that means in information set IB, player 2 will always play L. And in the same way, in information set IA, player 2 sees that player 1 always plays A, and if it plays L, it gets 0. If it plays R, it gets 1. So information in the information set IA, player 2 will always play R. Right? This is our proposition. In this case, the probability of player 2 in information set IA of playing R equals to 1. And the probability of player 2 in information set IB for playing L equals to 1. Right. And what we need to know in the last step, we need to confirm whether our assumption still sustains, whether player A will ever deviate to a different strategy. Now let's first look at player A's strategy at this point, at H1. If player A no longer, if player 1 no longer plays A at H1 but plays B, what will be his payoff? He will get a payoff of 0, right? But if he continues to play A, he gets a payoff of 1, and 1 is larger than 0. That means player 1 will not deviate at point H1. And we look at this. For player 1 at decision point H2, if he plays B, he gets 4. But if he deviates to playing A, he gets a payoff of 2. And 4 is larger than 2. So that means player 1 will not deviate from playing B to playing A. And our assumptions stay. right? So I will just write down the utility for player 1 of playing A given the strategy profile of player 2 and their beliefs about each other's type at decision point H1 equals to 1, which is larger than the utility than the payoff of player 1 of playing B at given the strategy profile of player 2 and their beliefs at H1, which is equal to 0. So we know that this assumption sustains, okay? And the same of playing B at sigma 2 mu at decision point H2 equals to 4. Utility, the payoff of player 2 for playing A given the action profile of sigma 1 and their beliefs at I wrote it down. I should rewrite it. We are still comparing the payoff of player 1. So this is player 1. 1. This is given the action profile of his opponent at decision point H2 equals to 2. And 4 is larger than 2. So our second assumption also sustains. So in the end, what is the action profile? The action profile is for player 1, he will always play A at decision point H1, and always play B at decision point H2. And for player 2, he will always play R in information set IA, and L in information set IB. So this is the WSE, the weak sequential equilibrium of this game. Okay.